Hello everyone, my name is Elena Grigorieva and today we're going to look at the point-to-point fixed network planning tool, which is a part of the automated map-based strategic network planning tool. We start here with the basics, that is really opening the ArcMap project. You will have a little bit less of the data there when you download this project, but this initial distribution will be there. So this is how it would look like if you open the project, and you can see that there is a toy example that you can work with, and this is what I will show the planning on. That we have a small area of a city near Munich, which is called Ottobrunn, with a placed central office and 4 base stations that are also abstractly placed there. Then we can open our tool. In order to open it, you don't have to install it or do anything else, rather than know where it is stored, and then you can just see it from ArcMap and open it and use it. So you can see here the GUI for all of the inputs that are required from your site. There's a description and also the filtering, so that it's impossible to input something that completely doesn't suit this one. So the first one is network dataset, and that is a specific ArcGIS format where the network analysis can be performed. Please notice that it can be only created in the feature datasets, not on the generic database. There are some examples in the data that is uploaded together with the project. So this is the first input that you have to input. Then you have 2 binary checks. You could do it with protection, and the protection could be then also shortest path. Then you need to input the demands, and the demands in this case are homogeneous, so they could be, as I show in this example, the macro base stations, or they actually could be also the buildings, because there are architectures when the buildings are also connected point to point, so it's up to you. The next parameter that I'm not inputting here, but it's theoretically possible to give, is the brownfield duct. That is, if you know that at some streets there are already some ducts that could be reused, you could give this information here, and it will be preferred to use these line segments instead of the new ones. Finally, there are just a couple of parameters that you need to include to get the results. So in the output directory, the text file with the fiber and duct links stored. In the output feature dataset, the actual results are stored. And then the output name just would make a differentiator for you. In this example, this tool with all the writing and everything, all the post-processing, runs for about 15 seconds. Larger examples would run for a couple of minutes, probably, depending on the complexity of the topology and the architecture that you want to see. So we can navigate in the catalog and also see our results. So first you can see the shortest path working fiber and duct. You can also open the attribute table and navigate through the individual routes to the base stations. You can also take a look at the total duct or at the protection. Everything is there, and in this example you also see that the protection is linked disjoint, shares one node, but other than that it's shortest path protection. You can also go through all the individual protection paths. Okay, so thank you for your attention. Bye.